So this is the Algebraic Expressions Final Assessment video review. So the commutative property is just stating that you can add in any order if all it is addition, and you can multiply in any order if all you're doing is multiplying. So 3 plus 5 is the same as 5 plus 3. Both of them are 8. As well as 2 times 6 and 6 times 2, both would be 12. And it doesn't matter how many numbers you are multiplying or adding. The associative property is very similar. It just states that when you add, you can group the numbers in any combination. And there's an example on the screen in both of those examples. They add up to 10. As well as multiplication, it follows the same rules. You can group them in any order. The identity property just states that the product of 1 and any number is going to be that number. So 6 times 1 will still be 6. The zero property of multiplication just states that the product of 0 in any number is going to be 0. So 0 times 9 would be 0. Or 0 times a variable would still be 0. And then the identity property just says that the sum of any number and 0 will still be that number. Distributive property. So here are some examples of the distributive property. So in the top example, you're going to distribute a copy of the 4 to the x and to the 7, where you'll multiply 4 times x and 4 times 7, which is 28. And your answer simplified is 4x plus 28. Some other examples are on the screen as well. Sequences. So a sequence is just a set of numbers, 3, 5, 7, 9. These are different terms. So the first term is 3, the second term is 5. It could be term, element, and then the 3 dots just mean it goes on forever. And to find the next 3 terms, first you have to find the difference between numbers. So the difference between 9 and 7 is 2. So you can do it by subtracting 9 minus 7. And then to find the next 3 terms, you take 9 and add 2, because that 9 was the last term. So you add 2 to get the next term, which is 11. And then you take that and add 2, and so on. So the next 3 terms in this sequence would be 11, 13, 15. How to calculate exponents. So exponents are written in the top right-hand corner of the number. The base is the bigger number and the exponent is a smaller number, and it just tells you how many times to multiply the base by itself. So 2 to the 4th power is 2 times itself 4 times. Evaluating algebraic expressions. To evaluate an expression like 2y plus 3, if you're given the value of the variable, y equals 4, step 1 is to substitute or plug in 4 for the y. So you just put it right into the spot where it is in the expression. And then step 2, you have to follow order of operations. And in this case, you'd multiply 2 times 4 first. And then you can add and get 11. Simplifying algebraic expressions. So an algebraic expression is in the simplest form if it has no more like terms and no parentheses. Sometimes you'll have to use distributive property. And in this case, you can use symbols or algebra tiles, which we'll talk about next, to add, or you can just add 4x plus 2x by adding the coefficients, which is the number in front of the variable. So 4 plus 2 is 6, and then keeping the variable, so 6x. To add algebraic expressions, you can either use algebra tiles or add the terms using columns. Here are 2 examples. Adding with algebra tiles might be easier at first, but eventually you'll need to learn how to add with columns. So just adding the x terms together and then adding the numbers. Review of algebra tiles. So remember, you can't add x terms and numbers together. You're only allowed to add together anything that has an x or anything that's a number separately. So here are some common representations of algebra tiles. So a green rectangle would just be 1x or x. A red rectangle would be a negative x. And then you have your squares, which stand for the numbers. So a yellow would be a positive 1 and a red would be a negative 1. Adding and subtracting. So this shows the difference between adding linear expressions and then a subtracting. So if you add and you have just an addition symbol in between two sets of parentheses, then you can just ignore the parentheses in this one because the addition doesn't change anything. So you can add everything up and you'd get your answer. But for the one on the right, if the subtraction sign is in between two sets of parentheses, it's important to realize that this means you're subtracting both terms inside. So you can either just distribute the negative, or I'll show you another way to do that. So in this example, the first one, I'm using Algebra Tiles, and I'm taking this whole first set, x, plus x, and a plus 1, and I'm going to subtract this next set, another x and another 1. And then you'll realize that the answer would be 0 because this, subtracting this, it's the same thing. In the second example, which is the same problem, you actually have to distribute the negative to both numbers. So you could do it this way instead, which is what I will suggest to do eventually, is to just rewrite the problem by distributing the negative to both, to the x and to the 1. So then it really becomes a positive x, a positive 1, and then minus an x and minus a 1. And everything would cancel out. And that is the end of the video. Make sure you go back and review anything needed. You can come back to watch this video at any time and pause where needed.